There are many different ways that the exponent rules can be explained, that they can be derived, that they can be shown. Another way to investigate where zero exponents and negative exponents come from is to look for a pattern in what happens when we raise 3 to different powers. So in the left column, we have 3 to the fourth. As a product, this means 3 times 3 times 3 times 3. And the value of 3 times 3 times 3 times 3 is 81. On the second line, we have 3 to the third. 3 to the third as a product means 3 times 3 times 3. And as a value, 3 times 3 times 3 is 27. 3 squared. The product means 3 times 3, and we know 3 times 3 is 9. If we stop to see what's happening, what we might notice over in the left column is every time we reduce the power by 1, over on the value side, we end up dividing by 3. Again, over in the power column, the left column, when we go from 3 to the third to 3 to the second, we've subtracted 1 power, and over on the value column, we've divided by 3. Also notice in the product column, every time we reduce the power by 1, not surprisingly, we have 1 less 3 in the middle column, in the product column. When we look at 3 to the first means we have a single 3 as a product, so it's not really being multiplied by anything, and the value of this is just 3. But again, notice the pattern continued. The power got dropped by 1, and the value was divided by 3. What we can do is we can use this to try to investigate what it means when we go one step further. If I take 3 to the first and I drop the power by 1, I'm going to be left with 3 to the 0. And if I go another step further and I drop that power by 1 again, I'm going to have 3 to the negative 1. And go one step further yet, drop it down by another power, we'll have 3 to the negative 2. The question is, what is that going to mean in the product column? What in the world could 3 to the 0 mean as a product, since we're saying we don't have any 3's? Well, if we ignore that column for the moment and take a look over at the value column, this will make sense. What is 3 divided by 3? We jump from 3 to the first to 3 to the 0, we need to divide by 3. Well, 3 divided by 3 is 1. And what about when we go from 3 to the 0 to 3 to the negative 1? We drop the power by 1, which means we need to divide the value by 3. Well, 1 divided by 3 is 1/3. And similarly, when we go from 3 to the negative 1 to 3 to the negative 2, we dropped the power by 1, which means over here in the right column, we need to divide the value by 3. And 1/3 divided by 3 is 1/9. So if we follow what's happening with powers and values, subtracting a single power means we're going to be dividing by 3. So the question is then, what does that mean for the product column? 3 to the 0 is 1. But if we continue down that product column, we know 3 to the negative 1 is 1/3. 3 to the negative 2 is 1/9. But thinking in terms of products and powers of 3, that's the same thing as 1/3 squared. So this gives us an alternate justification, not based simply on this is what the quotient rule did, but also on this is how the pattern falls out with the numbers. If we continue decreasing powers by 1, we end up dividing by 3, but what that in turn does is ends up with reciprocals. A negative exponent means you have the reciprocal. It's simply an alternate explanation of where 0 and negative exponents come from.